Welcome to the Unisys DMS2 tutorial video. This video introduces the field level encryption for DMS2 database, RDB over TCPIP, and new features for DMS2. The first topic is field level encryption, FLE. FLE is also known as item level encryption. This feature allows users to encrypt selected data items in the dataset, such as alpha, number, real, and group. It supports AES GCM algorithm. AES HMAC is another algorithm that is also supported. This serves as a backup algorithm in case AES GCM is compromised. DMS2 is integrated with Dmsii API calls to the firmware and also to the security center. Only NGM4 and above can use these features. All encrypted data items are moved to the end of a dataset record. This optimization allows DMS2 to encrypt every record only once. The encryption algorithm requires encrypted data to be multiple of 16 bytes plus 30 bytes for padding. This optimization not only reduces storage usage significantly, but also improves performance. Encryption of same text will result in a new encrypted text every time. Due to this, DMS2 uses hashing to handle key items of sets and subsets. Hashing is also strong and powerful and is one-directional. That means that the hashed key items cannot be converted back to plain text. The database encryption product will be available on these systems that require a firmware update available in late 2017. They are Libra 43 series, 63 series, 83 series, FS600, and current software series products. It will also be available on future server and software series products that will have the database encryption ready firmware and MCP 18.0. Dmsii API provides a new private connection library to DMS2. DMS2 uses Dmsii API as a conduit to interface with Security Center and Key Manager. The default encryption algorithm is AES GCM. AES HMAC is provided as a fallback in case AES GCM becomes weak due to an attack on the algorithm's security. DASTL calls Dmsii API to create a key set, one key set per database. A key set consists of a master RSA key and 16 FLE keys. The FLE keys are used to encrypt fields in the database. DMS2 assigns an FLE key to a structure in a round-robin fashion. The RSA master key is used to encrypt the FLE keys. Dmsii API status command provides status of encrypted database. FLE key sets are stored in the Security Center database. FLE key sets can be managed by Security Center Client GUI. This is the display of key sets of every database in the system and is displayed under Enterprise Database Server Keys node. Security Center allows the display and administration of the FLE key sets, including synchronization of FLE key sets. FLE key sets can only be created through DMS2. The size of an encrypted number key item must be in units of bytes. This is due to the requirement of AES GCM algorithm. If a set or subset has multiple key items and some of them are encrypted, one of the encrypted key items must be the major key. If a set or subset has multiple encrypted key items, each encrypted key item must start on a byte boundary. An encrypted group cannot be used as a key of a set or subset. Whenever you want to use a group item as one of the keys in the set or subset, declare the individual items of the group as keys rather than declaring the group itself. The ascending and descending options cannot be specified for an index sequential set or subset containing encrypted key items. Since DMS2 does not allow more than 300 structures to be reorganized concurrently, we recommend use of replace keys instead of new key set when changing the key sets. This applies to the key items specified with the data encrypt option. An access of a random, direct, or ordered dataset cannot contain encrypted key items. However, non-key items within the dataset can be encrypted if desired. An item specified with the data encrypt option cannot be used as key data. An item specified with the data encrypt option cannot be used as a part of select, verify, or where class. This is a restriction in the implementation, and if there is a need to remove this restriction in future, please let us know. An encrypted item cannot be used as key item for embedded sets. Only find equal is supported. This is because we hash the value. The find next and find previous will not be possible. Linear search is not supported if a user selection expression contains an encrypted key item and a non-encrypted signed numeric or real key item. Linear search does not support more than 15 keys in a single user selection expression. Online reorganization and online garbage collection are not allowed if a set or a subset contains any encrypted keys. The reason behind this is that generating a set from itself is not possible due to the hashing. A reorganization of a set or a subset with encrypted keys must be generated from its dataset. Reorganization cannot generate a manual subset with encrypted keys. We already talked about the replace key set earlier. This is the recommended approach. This feature allows RDB to work with TCPIP networks. The TCPIP network protocol is supported in addition to BNA. The choice is per database. So one database can use TCPIP while another database on the same primary host can use BNA. This is particularly useful when multiple primary databases on the same host are backing up to different secondary hosts. If the network protocol is TCP/IP, then FTP is used instead of NFT to transfer files between hosts. This includes the files transferred during the enable, clone, and audited reorganization processes and audit files transferred in AFS mode. For each database, administrators must specify a user code and a password for each host to the assigned to the RDB server task and also used by FTP. All passwords are obscured before being stored in the RDB control file. If a security center is installed, the passwords can be encrypted. Administrators must access Security Center to create a key container RSA key on the primary host and then export it to the secondary host. A service name of RDB support is associated with the container instead of a user code. Thus, all of the databases on a host, that use RDB over TCPIP share the same key container. Instructions for creating the key container are provided in the RDB Planning and Operations Guide. If a key container is not provided, the passwords are obscured using the same simple algorithm that is used by the data mask. Standard FTP exposes the password on the wire. FTPS can be used to secure the logon, but it requires configuring SSL and certificates on the two hosts. Therefore, administrators can specify which method should be used, FTP or FTPS. The default is FTP. In a TCP/IP only environment without BNA, host services is not available to perform remote tasking. Therefore, the RDB support library is configured as a DSS, Distributed System Service, in order to initiate RDB server tasks at the remote host. This configuration is performed automatically by simple install. Administrators can change the port number that is used. A configuration file is used to override the default DSS port number or to specify FTPS instead of unsecured FTP. If the file is not present, the default values are assumed. If TCP/IP end system security firewall is running, rules must be set at both hosts to allow the necessary TCP/IP connections for the DSS port and for the ports used for database communications and audit transfer. These rules are documented in the RDB Planning and Operations Guide. Some new feature suggestions have been implemented. Introduction to daemon to restore touched and removed database files. This happens at the next control point and only for those files which were touched. Allow offline dump when a database is disabled is another feature. The third feature is during cloning, allow user to set parameters, database parameters for a secondary RDB secondary host in Database Operations Center. Enterprise Database Server for ClearPath MCP Utilities Operation Guide. Enterprise Database Server for ClearPath MCP Data and Structure Definition Language (DASTL) Programming Reference Manual. Remote Database Backup Planning and Operations Guide. These are all having additional information. Thank you.
We hope you found this presentation useful and informative. Unisys offers a comprehensive set of ClearPath Forward services to enrich the value of your ClearPath Forward applications, data, and systems. Please contact your Unisys representative for more information. Thank you for your continued use and support of Unisys ClearPath Forward systems. Good day.